Alright, this video I'm going to talk about binomial distributions. Before I get to that, first off, we should probably talk about what a binomial experiment is. First off, binomial experiment has a few things. We need n independent trials. That's one of the important pieces. We need n independent trials. So you have some sort of amount of trials you want to do, they need to be independent. The other thing you need is each trial has either success or failure. So each trial has a success or failure, and we'll talk about what that means in our example. Additional with those, each success and failure, the probability of success, which we designate that as P, is constant, meaning it's always the same. So the probability of success P is constant. So we have n independent trials. Each trial is a success or failure. The probability of success P is constant. So when we're doing these problems, there's three things that we care about. We care about n, which is our trials. We care about P, which is the probability of success. And then the other thing we care about is K, which is the number of success. So when we're doing these problems, there's our binomial formula we have. So I'm going to write that down. We're going to use it a whole bunch of times in this video. So if you ever want to know the probability of K successes, so for example, if you're flipping a coin 20 times, and you want to know, hey, what's the probability that I flip and I get exactly 13 heads? You're going to use this formula. It starts off with first the combination, n choose k, times p raised to the exponent k, times 1 minus p raised to the n minus k power. So if you ever want to find the probability of any number of successes, you plug in n for trials, k for whatever number of successes you want, and p for the probability of success. So, in our example, according to a survey, about 85% of people ages 18 and older in the U.S. use the internet or email. We're going to ask 4 randomly chosen people, ages 18 and older, whether they use the internet or email. So what we need to do first is draw a histogram of the binomial distribution of your survey. First thing I like to do is I like to pick out, well, what is n and p, and make sure this is binomial. So n is, we're asking 4 randomly chosen people. Since it's randomly chosen, that's going to make it independent. So we're asking 4 randomly chosen people whether they use internet or email. So we want to know what's the number of people that use internet or email. So our success would be someone saying yes, they use internet or email. Failure would be they do not use internet or email. And that probability is going to be constant because they tell us the probability that they use internet or email is 85%, but we're going to use the decimal equivalent 0.885. So what we're going to do is we're going to draw a histogram of the binomial distribution for your survey. So let's think, if we're asking 4 people whether they use internet or email, what are all the possibilities of that sample of 4 people we ask? How many of them can say they use internet or email? Well, we end up with k equals 0, which means none, 0 of the 4 say they use internet or email. We can have 1 of the 4 saying they use internet or email. We could have 2 of the 4 saying they use internet or email. You get the idea. 3 or 4 out of 4 use internet or email. So what we want to know before I get to the histogram part is I want to know what's the probability that I have 0 out of 4 saying they use internet or email. What's the probability that 1 out of 4 uses internet or email? What's the probability that 2 out of 4, 3 out of 4, 4 out of 4? So I want to know what's the probability that we get each of these. And the way we're going to do that is use that formula I had earlier. We're going to plug in n for each of the pieces for n. We're going to plug in this 0.85, sorry, for p, and our k is going to change for each one. So we're going to start with k being 0, then we're going to do k equals 1, k equals 2, k equals 3, k equals 4. So I'm going to write out what this looks like by formula, and then I'm going to show you how to plug it into a calculator. So this would be 4 is n, combination k, and this time is 0. So 4 and 0 for my n and k. My p, put that in parentheses, 0.85 raised to the k, but k was 0. And another parentheses, 1 minus 0.85 raised to the n minus k. So n was 4 minus k, which in this case was 0. And basically what you're going to notice as you rewrite this for k equals 1, k equals 2, the only thing changing is k. So my 0s become 1s, my 1s will become 2, my 2s becomes 3, 3s becomes 4s. So my second one will be 4, choose 1, 0 changes to 1, 0.85, instead of 0 we're going to write 1, 1 minus 0.85, instead of 4 minus 0 I'm going to have 4 minus 1. And you're going to notice that changes. Now the 1s will all become 2s. So 1 minus 0.85, 4 minus 2. 4, choose 3, 0.85, 3, 1 minus 0.85, 4 minus 3. 4, choose 4, 0.85, 4, 1 minus 0.85, 4 minus 4. So I write it all out first, and what I'm going to do is I'm going to calculate each of these probabilities in my calculator. So I'm going to show you one, and then the rest of them you can pause the video and do that on your own. So the first thing I need for this first one is 4 choose 0. So on my calculator, if I want to do the combination 4 choose 0, I have to do a 4 math PRB NCR 0 times, I'm going to put parentheses 0.85, parentheses raised to the 0, go over, then have parentheses 1 minus 0.85, parentheses raised to the 4 minus 0. And what we get is 5.0625 e to the negative 4. That is scientific notation telling you need to move the decimal 4 places to the left. So we're going to get 0.0005. And that's how we do it in the calculator. I'm not going to do the rest of them, so it's going to be 0.011475 for this one. And again, if you want to see these, you could pause it, type it into your calculator, check and see if you get the same thing. 0.0975 for this one, 0.3685 here, and 0.522. So the probability that we have 0 out of 4, say they use internet or email, is 0.005. The probability that 1 out of 4 use the internet email, 0.011475. You get the idea. So what we need to build is a histogram here. Basically represent these numbers in a bar graph of sorts. So the x value, or the bottom of this graph, I'm going to use number of people that use internet email. And we had that it could be 0, 1, 2, 3, or 4. And what we're going to have as our y-axis there is the probability of this happening. Now, my probabilities went from 0.005 all the way up to 0.5222. So what I'm going to do is I'm going to have 0, we'll put 0.1, 0.2, 0.3, 0.4, 0.5, all the way up to 0.6. And all we're going to do is make a bar graph of sorts. So when we had k being 0, my probability was 0.005. So we're barely going to put a sliver there. So just a sliver. There's my bar graph for 0 out of 4 saying they use internet email. Next I have 0.011475, so still tiny but a little bit bigger. Bar graph for 1. 2, we got up to 0.0975, so that's going to be just below 1, or 0.1. So we're going to go up here, go over, so that's 0.2. Probably that we had 3 that use internet email, 0.3685. That's going to be all the way up here, roughly. Doesn't have to be perfect, but you want to make it look as close as possible. And then 4 is 0.522, so we need to go above the 5 just a little bit, right there. So you just make a bar graph of all of your values, 0, 1, 2, 3, 4. 2 questions to follow up from this. The first one, what is the most likely outcome of your survey? Well, you could just look at the histogram. Which bar is biggest is the most likely to happen. So it looks like the most likely outcome is this 4 here. So our most likely to have 4 out of 4 say they use internet/email. So 4 out of 4 will likely say that. Part C, what's the probability that at least 2 of the people you survey use the internet or email? So pay very close attention to at least 2. So that means 2 use it, or you can have 3 use internet and email, or 4 use it. Now I'm not going to flip back and forth, but the probability that we had K being 2 was 0.0975. The probability that our K being 3 use was 0.3685. The probability that we had 4 use was 0.522. Well, what do we do with these 3 numbers? Well, it's 2 use or 3 use or 4 use. So we're going to add all those up, and when you do, you get 0.988. So 98.8% chance that you have at least 2 people out of the 4 surveyed say they use internet or email. And that was binomial distributions.